How does a massive airplane stay in the air? Let's uncover the forces that make flight possible and explore the fascinating science behind it. 4 main forces govern flight: lift, weight, thrust, and drag. Lift is generated by the wings as air flows over and under them, creating an upward force that counteracts the plane's weight, the downward pull of gravity. The shape of the wing, called an airfoil, is specially designed so the air moves faster over the top surface and slower underneath, producing a pressure difference that lifts the aircraft. Modern airplanes have highly engineered wings, often with flaps and slats, which help increase lift during takeoff and landing when extra support is needed. Weight is the force caused by gravity pulling the plane toward the earth. Everything on the aircraft, including passengers, cargo, fuel, and even the structure itself, contributes to the total weight. Pilots and engineers must carefully calculate the maximum takeoff weight to ensure the plane can achieve lift without straining the engines or compromising safety. Fuel management also plays a role because as the flight progresses and fuel burns, the weight decreases, slightly affecting performance and handling. Thrust is the force produced by the engines, pushing the aircraft forward through the air. Depending on the type of plane, thrust can be generated by jet engines, turbofan engines, turboprops, or even propeller engines in smaller aircraft. Jet engines work by sucking in air, compressing it, mixing it with fuel, and igniting the mixture to produce a high-speed exhaust that propels the plane forward. In contrast, propeller engines use spinning blades to pull air backward, creating forward motion. Thrust must overcome drag, the resistance created by air as the plane moves through it. Drag can be affected by the plane's shape, surface smoothness, and speed. Engineers spend countless hours designing aerodynamic bodies to minimize drag, improving fuel efficiency and speed. The 4 forces work together in harmony. For steady, level flight, lift must balance weight, and thrust must overcome drag. If lift is greater than weight, the plane climbs. If weight is greater, it descends. Similarly, if thrust exceeds drag, the plane accelerates. If drag exceeds thrust, it slows down. Pilots control these forces using a combination of engines and control surfaces. Ailerons on the wing's control roll, elevators on the tail control pitch, and the rudder controls yaw. By coordinating these surfaces, pilots can climb, descend, turn, and maintain stable flight, even in turbulent conditions. Understanding the 4 forces also explains phenomena like turbulence, stall, and supersonic flight. Turbulence occurs when uneven airflow temporarily disrupts lift and drag, causing bumps or sudden shifts in altitude. Pilots anticipate and manage turbulence to keep flights smooth. To stall happens when the wing's angle of attack becomes too steep, reducing lift dramatically, but proper pilot training and design features prevent accidents in high-speed aircraft, such as military jets or supersonic airliners. Engineers design wings and control systems to handle the extreme effects of air pressure. drag, and temperature at Mach speeds. Aircraft, like the Boeing 737, require approximately 20,000 pounds of thrust from each engine to take off. And even larger planes, like the Airbus A380, use engines producing over 70,000 pounds of thrust each. Fuel efficiency, engine power, wing design, and weight distribution all work together to achieve takeoff, cruising, and landing safely. Pilots continuously adjust throttle settings, trim, and control surfaces to maintain the perfect balance between lift, thrust, weight, and drag during every phase of flight. In addition, modern aircraft use technology like autopilot, fly-by-wire systems, and flight computers to assist pilots in managing these forces efficiently. Autopilot can control the plane's attitude, speed, and navigation with precision, while fly-by-wire systems translate pilot commands into electronic signals that adjust control surfaces instantly, ensuring smoother and safer flight. These four forces of flight are fundamental to everything in aviation, from tiny drones and private planes to massive commercial jets and supersonic military aircraft. They are why airplanes can soar gracefully across the sky, maintain stability during long-haul flights, and reach destinations safely and efficiently. Without understanding and mastering these forces, modern aviation as we know it would not exist. Now that we understand lift, weight, thrust, and drag, we can appreciate the incredible engineering and skill required to make flight possible. In the next video, we will explore aviation milestones that changed history, from the first powered flight to the fastest jets ever built, and see how humans have continuously pushed the limits of flight.